Hi friends, so last video we were looking at this notation for matrices. So we came up to this Ax equal to b, and then there was the stacking the columns that I was mentioning, and I was looking for the figure. Actually it was not in another page, it was in the same page on the left hand side that I completely missed. So let's just look at the quickly the stacking of the columns. Nothing complicated there, it's exactly this. They have a very simple example of a 4 by 2 matrix, right? So let's take a 4 by 2 matrix, okay, which means it has 4 rows and 2 columns, right? So it is like this. So we have 4. So I'm going to have 1, 2, 3, and then let me make it a little bit bigger. I'll close it once I write the numbers, right? So it's going to be, let's say 1 minus 2, I'm just writing some random numbers, 0 and 4, right? So this is one column, and then in another column, let's say we have minus 1, 4, 2, and minus 6. Okay, now this is a 4 by 2 matrix, right? So I have written integers, but this can be any real numbers also, it doesn't matter. And then the stacking means we take these and then we just, so this is matrix A, and this is in R4 by 2, right? And then we are going to do reshape. This operation is called reshape, which means we are going to change the shape of these numbers, right? 4 by 2, and then we are going to stack them vertically, right? So it's going to be twice the size. So 1 minus 2, 0, 4, minus 1, 4, 2, minus 6, right? And this is called the reshape operation, or what the authors are calling as column stacking. Okay, nothing complicated there. This might be useful for doing some mathematical operations in a more efficient manner. Okay, so now we move on to section 2.2.1, which is matrix addition and multiplication, right? So matrix addition and multiplication. Okay, so the sum of two matrices, you can add two matrices only if they are of the same dimensions. So if you have a matrix A which belongs to R m by n, and then if you have a matrix B which also belongs to R m by n, then it's easy to see how A plus B is defined, right? A plus B defined as, so for the first element, which is going to be, so this is m by n, this is m by n, so the dimensions are the same, both are m by n, and we are going to take the first element, the top left element of this, and add it to the top left element of this, and then the corresponding elements get added. So each one is going to be like A11 plus B11, right? And then this will go all the way up to A m1, so there are m rows, plus B m1, right? And then this is going to be carried out all the way up to A1n plus B1n up to AMN plus BMN, right? And this is again, this matrix also belongs to Rm by n. Okay, that's just component wise. You take each component and then just add it up. So that's about it, right? And so this also, sometimes this notation is used, right? So there is this alternate notation where sometimes they write like Cij, right? This is lowercase c equal to A I j plus B I j, right? So this is the same thing as A plus B. Okay, this means every I jth ith row jth column element of this C is basically taking the ith row jth value of matrix A, ith row jth column value of matrix B, and adding them up. Okay, and that's how this whole matrix is defined. So this here I can be anything from 1 to m, and j can be anything in 1 to n. Right? And then for multiplication, so now we are moving on to, so multiplication, we kind of saw this in the previous lecture where we did the column vector. For multiplication, if you have again a b in so a b cannot be like this. For multiplication, actually let me use a new sheet. Maybe I'll cover it in the next video here. So matrix addition we have done. We'll cover matrix multiplication in the next video.